Everyone. This is our project VitalOps. Our project is a real time health monitoring system that uses actual hardware to track vital signs like heart rate and oxygen levels.
Alright, so here's what we are working with on the hardware side. This is Arduino Uno R4 plus Wi-Fi, which is a versatile microcontroller that acts like the brain of our setup. This right here is Max 30102 PPG sensor, which is a low power integrated pulse oximeter and heart rate module. It uses PPG to measure the heart rate and blood oxygen saturation, that is SpO2 levels. How it works is it shines light, red and infrared, red 660 nanometer and infrared 880 nanometer light into the skin, and blood absorbs light depending on the oxygen saturation and volume. Through that, we calculate the SpO2 and the heartbeats per minute. How we done is, let's understand it with the code. These are all the libraries that are included. Arduino HTTP client for sending the data, SpO2 algorithm for calculating SpO2, Wi-Fi module for connecting to the Wi-Fi, and Max 30105 for connecting to the sensor. Okay. First we set up all these default values and then connect to the Wi-Fi. Then we detect the finger. If finger is detected, then it is proceeded, otherwise not. We calculate 100 samples over 10 seconds, and then finally we calculate the SpO2 and heart rate values. After calculating, we send to the API at slash API slash vitals endpoint. The response is received as the API status and the status code, and the program stops after one reading.
The dashboard, you can see the live heart rate and oxygen levels updating automatically. The dashboard also shows status labels like normal, warning, or critical based on the data, so caregivers can easily spot when something's off. We have set it up to show recent history too, so trends can be tracked over time. So, why did we build VitalOps? Remote health monitoring is really important, especially for people who can't visit doctors regularly, like the elderly or patients with chronic conditions or patients in remote areas. Our system helps caregivers and doctors keep an eye on vital signs in real time so they can catch any problems early and provide timely care. Behind the scenes, we use a CI CD pipeline with GitHub Actions to automate building, testing, and deploying the app. This means whenever we update our code, the app gets automatically rebuilt and deployed, no manual work needed. It helps us keep the system reliable and always up to date. Now, let me quickly show you how our CI CD pipeline works. This is important because it lets us update and deploy the app automatically so users always get to see the latest features and fixes without any downtime. Here you can see the pipeline running on GitHub Actions after we push some changes. It starts by building the front end and back end, then run tests to make sure everything works fine. Next, it builds a Docker image with the full app, pushes it to the container registry, and triggers deployment to our hosting service. Once the pipeline finishes, the updated app goes live automatically, no manual intervention needed. This CI/CD setup makes our project reliable, easy to maintain, especially as we keep improving it. As you can see, our pipeline is currently building a Docker image. And as you can see, it's going through all of the process. Uh, Thanks for watching our demo of VitalOps, a health monitoring system built at the intersection of healthcare and DevOps. We are excited about the potential impact this project can have in making healthcare more accessible and reliable.